Welcome to clickmeproject.com. Let us see the demo of exploring sequential probability tree for movement-based community discovery. In this process, we tackle the problem of discovering movement-based communities of users, where users in the same community have similar movement behaviors. Note that the identification of movement-based community is beneficial to location-based services and trajectory recommendation services. Specifically, we propose a framework to mine movement-based communities which consist of three phases: constructing trajectory profiles of users, deriving similarity between trajectory profiles, discovering movement-based communities. In first phase, we design a data structure called a sequential probability tree. A user trajectory profile. A sequential probability tree not only derives the sequential patterns but also indicates the transition probability of movements. Moreover, we propose two algorithms, breadth first and depth first, to construct sequential probability tree structure as user profiles. To measure the similarity values among user trajectory profiles, we further develop a similarity function that takes sequential probability tree information into account. In light of the similarity values derived, we formulate an objective function to evaluate the quality of communities. According to the objective function derived, we propose a greedy algorithm GeoCluster to effectively derive communities. To evaluate our proposed algorithms, we conducted the comprehensive experiments on two real datasets. The experimental results show that our proposed framework can effectively discover movement-based user communities. Additionally, user trajectories can be detected by GPS-enabled devices. When user enters a building, the user may lose the satellite signal until returning to outdoors. By matching user trajectories with stored information, a user moving sequence among stores in some shop areas can be extracted. In this proposed system, we consider the mining EFSP using systolic tree, which accelerates the speed of processing the existing works. Data mining, which is exploration of knowledge from large set of data generated as a result of various data processing activities. Frequent pattern mining is important task in data mining. The previous approaches applied to generate frequent set generally adopt candidate generation and pruning techniques for satisfaction of desired objective. Frequent pattern mining in transaction database is one of well-studied problem in data mining. One obstacle that limits the practical usage of frequent pattern mining is extremely large number of patterns generated. Such a large size of output collection makes it difficult for users to understand and use in practice. Even restricting the output to border of the frequent item set collection does not help much in alleviating the problem. Based on request made by registered client, the pattern mining is indulged to process through functions such as requesting for clients available for choosing among the list of systems. The system refers with registered data from database seeking for solutions about particular domain, where frequent sequential mining is handled with proposed systolic tree approach to respond back to request as fast as possible. The domain is considered by tracing the mobile environment through the GPS trajectory technique. The system flow is continued by processing the database of domains and the patterning mined, which provides required information from system. The frequent and sequential item set can be determined by considering the flow between preprocessing technique and frequent pattern mining database is built, and the details of further change made by requester is added, which maintains the database consistency to look into gathering updated information. The updated record is utilized for future pattern recognition. Until recently, it was nearly impossible to gather large amount of data about connections that play such important role in our lives. However, this is changing with explosive increase in use, popularity and significance of online social media and mobile devices. The online aspect makes it practical to collect vast amount of data, and mobile element bridges gap between our online and offline activities. Unlike other computers, phones are aware of location of users, and this information is often included in users post. Our process starts with data loading and pre-processing. In pre-processing step, the garbage value should be removed. We are taken the census data set. After that pre-processing, the Euclidean distance measure applied to measure the distance between the data objects. After that, we formulate the sequential probability tree. After constructing sequential probability tree, we analyze the latent Dirichlet allocation clustering for finding the community. Finally, user can getting the community for following the trajectory information. Let us run our process. In the first step, user has to select the data set. The location selected and view the content of the location dataset. After selecting the dataset, user has to pre-process the dataset for removing the garbage value. Display the pre-processed data. User has to select the current location of. This is the latitude and longitude of user location. Calculate the Euclidean distance of the user location and other locations. This is the Euclidean distance between user location and other locations. This is the sequential probability tree. This is bottom-up approach. This number of community formed. The number of community discovered. There are 4 communities are discovered. The user locations are get and find the user community. This is the user's final community. Thank you.